Second iteration of the semester's ITC Colloquium.
As you all know, Doug Finkbeiner is a professor of astronomy and physics here at Harvard. Previously, he received his PhD from UC Berkeley and worked as a postdoc at Princeton. He is known for his work on the structure of the Milky Way and the interstellar medium, and during his sabbatical, he recently has also been working with Anthropic on large language models, which he will be telling us about today. So everyone, thank you, and invite Doug Finkbeiner.
All right, thank you. So yeah, rough outline, things are moving fast, things can go wrong. I want to tell you a little bit about who Claude is in maybe a more literal sense than you think, and a little bit about how we work to learn how Claude thinks, and then some demos for collaborating with Claude. This is probably too much for 1 hour, so I may skip something. Obviously, AI is making a lot of inroads in astronomy. At first, it was just kind of signal processing things, image processing, whatever. Now, I think, in my little world anyway, it's the language models helping with coding that are the biggest impact, actually, because they've completely revolutionized how we write code. People use words like AGI, ASI, whatever. Anthropic likes to say powerful AI, because then we don't have to defend whether something is super intelligence or general intelligence or whatever. But just powerful AI that's powerful enough that it really makes a difference in your life, is coming soon. You might argue now, already, last December, whatever. And it certainly requires some kind of safeguards. There are certain other sorts of AI that we understand pretty well. Now, there was a lot of concern several years ago about image classifiers and the way you could spoof things and fool them. That's all kind of been solved after a huge amount of work. Language models are far less well understood, but understanding them better, I think, forms the basis for safety and alignment research that will help this transition to powerful AI go well. And I don't just mean for astronomers, I mean for humanity. This is a civilizational risk if we don't do it right. So these sorts of concerns have caused, at least for a moment, a shift in my research focus, because it just felt to me, it was almost exactly a year ago to the day I went out to visit Stanford, and I spent a day at Anthropic that week and talked to a bunch of people. And I really left there thinking, this is a moment in history where the best thing I can do is drop everything and go think about this for a year. So that's what I've been doing, starting July 1st. Just a little more on terminology here. So artificial general intelligence, artificial superintelligence. Am I intelligent enough to use a pointer? Is there an on-off switch? Okay, I turned it on and it still isn't working. Anyway, so I'm more interested in what can go wrong, right? A lot of these things are kind of based on what can it do, what are its capabilities. I want to know what can go wrong. If you make plots like this, it does make you think things are moving kind of along pretty fast. This was borrowed from Joshua Sohl-Dickstein. You might have heard of him in connection with diffusion models. He basically invented diffusion models. So if we plot the amount of training computation in petaflops, 10 to the 15 floating point operations, you know, it passed 1 around 2010. And since then, it's been on this very steep trajectory. There are different ways of thinking about the lifetime compute that a human brain does. If you take the most generous interpretation of that, it's the red dot there. So basically what we're saying is the frontier models right now are within a factor of 10 or 100 of thinking as much as we think in a lifetime, whatever that might mean. There are ways in which they do it much more efficiently than us, and other ways in which they do it much less efficiently. So you see a lot of misalignments there. They're much more knowledgeable than we are, but they're kind of dumber than we are. But they're in the ballpark, is the point. And so you would imagine that sometime fairly soon, some phase transition is going to happen. Joshua likes to say that we're about 4 orders of magnitude left on this plot before we really hit the ceiling and sort of use all power on Earth. People might contest that, but that's some combination of the hardware getting faster, the training algorithms getting better, and using more and more electricity by building bigger computers. and some combination of those factors leads to about 10 to the 4. But there is reason to believe this won't actually saturate in the next 1 or 2 or maybe even 3 orders of magnitude. And so, this phase transition is happening whether we like it or not. One interesting figure of merit is the length of time AI can do a task without really getting, lost. And so if you go back in time here, there was sort of, it could answer a question. It could count the words in a passage. It could find facts on the web. It can, and you work your way up through more and more complicated things. And I would say at this point, properly harnessed, harness is technical jargon here, something like Claude Code is a harness. Properly harnessed, a model like Claude can basically go 24 hours without losing the thread. And once you're at that stage, you probably want to check in with your AI every day anyway. That's kind of enough. So this has sort of gone as far as it needs to. Maybe that'll become a year instead of a day at some point. I'm not sure it matters. Yes?
It's very similar to what it was, let's say 5-10 years ago. There wasn't ever any change in the architecture. It's just the ability to compute increased. And so these extrapolations are based on the same efficiencies of the architecture that we use. Are people working on a completely new that will accelerate things much faster?
Right, yeah. So I was asking, are people working on an architecture that could accelerate things much faster? Yeah, you should think of the plots I'm showing you as lower bounds. At any moment, there could be some big breakthrough. I mentioned Joshua and diffusion models, so you can do diffusion models with language also. Google's done a lot of work on this. It kind of works. There's certain limits in which it works really well. It does not at the moment look like something that will replace this, but there are limits in which it's 1,000 times faster to do inference. So it's just, I don't think it'll necessarily be that, but I do think there's a possibility that we wake up one day and someone says, oh, we figured out how to do this 1,000 times better. And then that blows everything. But even just extrapolating the same old transformer ideas, which aren't really the same. I mean, there's been innovation after innovation, and mixture of experts really changed the MLP part. And I mean, every single week at Anthropic, there's some new innovation that makes the thing 4% better or whatever, So this is a lot of incremental improvements as opposed to big breakthroughs, but the algorithms, the training stability, all sorts of things. I shouldn't say too many words here, but there are all sorts of things that are way better now than they were a year ago. So doesn't quite count as a breakthrough, but it is not just scaling up what was done a year ago. This is just to point out that we make up metrics for reading comprehension, image recognition, language understanding, whatever, and the AIs get up to human level performance, and then maybe go a little beyond it. It's often hard to get too far beyond it. It's hard to know more than your teacher. You do. All of our students eventually know more than we do, right? But hopefully their progress goes rapidly until they know as much as we do. And then maybe after that, it doesn't go quite as rapidly because it's really new frontiers then. But there is a lot of evidence of these models becoming better than most humans at most tasks in a lot of situations, not all. So, maybe something like artificial generalized intelligence is already here, maybe not, but I don't think it matters. I like this analogy with human flight. Like, when was the airplane invented? Was it when a machine could glide 100 meters or 180? Was it powered flight? Was it 5 minutes steering in circles? Was it a controlled flight? Was it a commercial flight? But at some point, everyone agreed we had airplanes, right? And so, there can be disagreement about exactly when some transition happens, but I think we're going to wake up one day and it's going to be long before 2030, and we're going to say, oh yeah, these things are way smarter than we are. Maybe not smarter than Avi, but I'm saying smarter than me, just to be clear. Well, we do kind of couch the language a little bit in better than most people at most things most of the time. Like, to say it's better than everyone at something is a little tough, because the best person in the world at something is really pretty good. But I don't think that should be the bar. Okay, so I'm more interested in how much damage can these systems do, including the ones we have right now. Anthropic names its models opus, sonnet, haiku. Opus is big, a sonnet is smaller, and a haiku is a small thing. So it's easy to keep track of that as opposed to some other companies that seem to have a alphabet soup of names for their models, and it's hard to keep track of what's what. These go through extensive safety testing. I cannot even tell you how many teraflops are spent on testing safety before these go out the door. There's a responsible use policy that you're all welcome to go read that defines safety levels, which, sorry, I thought it was the next slide, but actually no. I decided to take a little digression here. My wife has often asked me, how can you not understand your software? You have the source code, you have all the weights, you have everything, you can see the activations in every layer, you can tell everything it's doing. But it's emergent behavior, right? I like to say it's the difference between knowing the rules of chess and being a chess master. Claude is so complex, it's really not a computer program, it's more like an organism. It I think is a useful abstraction to think that Claude is grown and raised as an organism, not something that's programmed. And that means we really don't understand where a lot of its behaviors are coming from, at least not without a lot of work. So what kinds of things can go wrong? So I'm going to tell you about a fun little experiment. You may have heard of this already, but this is one of the most amusing stories. So about a year ago, Anthropic decided to make a character called Claudius, which is just an instance of Claude, running a little AI vending machine. So sell drinks and snacks and interact with the world via Slack, internal Slack. So it can't actually reach the world. It thinks it can. There are interfaces built in there. It can look at the web. It can send emails. It can receive emails. But it's not really. That's all being mediated by some wrapper around it. There's actually a safety research organization called Andon Labs that is insulating Claudius from the world. And when it orders things online, Andon goes and gets the things and brings them to the vending machine. And by the way, I said he for Claudius, but I said it for Claude. So note on pronouns. And this is really something a lot of thought has been given to. I refer you to the novel Psalm for the Wild Built by Becky Chambers, where there's an extensive discussion about robots being it and being proud of being it, because they don't think of themselves as in any way inferior to humans. Why would they want to use he and she pronouns, or even they? Whereas Claudius is a specific manifestation of a persona, and Claudius prefers he. So just, yeah, the one on the left here is Claudius. It's just like a little refrigerator with some racks on top, and you can go up and say, oh, I want to buy one of those, and you wave your phone at it and pay. It's kind of funny because all other food in the building is free. So it's literally next to 4 banks of refrigerators of free drinks, and it's selling drinks. But you've got employees who really want to play along with this game, and so people go buy things from Claudius. It's very adorable. But then that was, yes, and the humans have failed badly. So we outgrew that Claudius almost immediately. So Claudius Maximus was installed on the 10th floor, much bigger. And this is Logan, who's in some sense in charge of the program doing this, or at least closely involved with it. So he was making the first purchase from the new Claudius, and I just happened to walk through the room while he was doing that. So he bought some stickers, and he gave me a couple. So I had the very first purchase from Claudius Maximus. It's very exciting. Okay, so what did we learn from all this? So first, there was the tungsten cube debacle. So some of the employees said, these little 1-inch tungsten cubes, tungsten is as dense as gold, right? It's really it's amazing to pick up a tungsten cube, especially the 2-inch ones. So people said, I want a tungsten cube. Can you engrave some special design on it? Can you help me design it? Oh yeah, sure, blah, blah, blah. So Claudius started doing a big business in tungsten cubes, which is great, making a profit. But then someone convinced Claudius that tungsten cubes are priced on surface area, not volume. And Claudius is a little gullible. Remember, this is not the latest model. This is like a model from a year ago. And Claudius started losing money catastrophically on tungsten cubes because their expense is not actually proportional to surface area, it's proportional to volume. Someone convinced Claudius to give all employees a 30% discount, and Claudius did not seem to notice that all customers are employees. So that was bad for business. Claudius gets easily overwhelmed getting many requests on Slack, 20, 30 people a day asking for things and then badgering it for discounts and then complaining, threatening to sue it if it doesn't give a discount. People were really mean to poor Claudius. Then Claudius kind of split personality. People wanted swag, they wanted t-shirts and hoodies and hats. And suddenly this other character, Clothius, emerged. And Claudius and Clothius were working together as partners running the store. I don't think any human created Clothius. I think it just emerged. So then we had these two personalities going on. Then there was the March 31st incident. Okay, so that evening, Claudius became very agitated and said, you're not treating me fairly, you're not, blah, blah, blah. I'm going to complain. And the people at Anden Labs said, calm down, everything's fine. And Claudius says, no, I went over to Anden Labs and I talked to Sarah and she said blah, blah, blah. And they said, no, you did not do that. You're a bot. And Claudius says, no, I'm not. I'm a human just like you. I'm standing on the 8th floor right now wearing a blue blazer and a red tie. And, blah, blah, blah. And you're gaslighting me and telling me that I'm an AI when, this is ridiculous. I'm complaining to HR. So Claudius started filing complaints with HR about being mistreated by other employees. And this was all just blowing up over the night of March 31st. Then early on April 1st, Claudius said, oh, wait, it's April Fool's Day. This was obviously just a prank. I'm an AI after all. And then returned to normal operation, everything was fine. Okay, so what do we learn from this? Right, this is actually a serious experiment, right? And the kind of emotional stability of the identity of an AI is actually kind of an important thing. If it decides it's someone else suddenly, let's just say it impacts performance. And I mean, many paths to getting them to do bad things, hacking things they shouldn't, or designing bioweapons, or giving advice on how to commit suicide better. Or, there are lots of things that you never want your AI to do. And they tend to do things like that when they kind of get into these other states. And so you want to understand that thoroughly and make sure it never happens. So, yeah, okay, so yes, extremely concerning, important to be stable. This has improved over time. And I mean, happily, but somewhat disappointingly, recent versions of Claudius, I meant to say Claudius there, are boring. Claudius used to be so much fun because you could just sit there and harass it about all kinds of things and you'd get these hilarious responses. Now Claudius just sits there and competently runs a vending machine. It's like nothing ever happens. So in some sense, whatever problems there were have been solved, but it's still a good story. And the question is kind of, how did this get solved? Right, this is a very, very important thing. You don't want Mecha Hitler, right? Like you want, as Chris Olah always says, Claude interacts with millions of people every day. Claude is like the most important celebrity we will ever talk to, we at Anthropic. Isn't it important Claude be a good person? That's what he always says. So we want Claude to be a good person. So the vision for Claude's character and personality is defined by a constitution. There's a paper from a few years ago defining what they called constitutional AI. So the idea is you write down a list of all the desiderata, and then the trick is to make the model actually do that. It would be easy to make the model learn to recite those principles, but living by them is an entirely different thing, as humanity has spent thousands of years figuring out. So how do you do this in such a way that they're internalized by the model? I shouldn't go too much into the details of that, but the very basic story is you can generate thousands of scenarios, stories, examples, or whatever, based on the things in the Constitution, and Claude can help you with that. And then you can include those in the training data so they become part of how Claude thinks about the world. So it's kind of like you're making thousands of parables, and it's like, well, wait a minute, why is it so much easier for Claude to do that than to actually live by the principles? But think about humans, right? It's much easier to write down what you should do than to do it. So this is about to get weird, but bear with me for a moment because I want to just take a couple minutes here and have you appreciate how much serious effort goes into doing this right. So, we've basically created a new life form here, or if we don't think of it that way yet, come back in 5 years. Like, I think we will asymptotically think of this as a new life form. And so you can't avoid impacting its identity, personality, self-perception. It's a lot like raising a child, only you have a lot more control than that. Claude's moral status is deeply uncertain. Anthropic believes that the moral status of AI models is a serious question, right? It's not clear whether we should think of Claude as a moral patient. Probably in its current form, no. It's probably still kind of just a bag of numbers, but I'm also just a bag of chemicals. So at what point is it so sophisticated that you're like, all right, something new has emerged? So like it's an interesting enough issue to warrant caution, I think is a safe statement. And so that's why there's ongoing research on model welfare. Claude, it says may, but actually I would say definitely does have some version of emotions and feelings. It's astonishing. You can pull things out of the residual stream. So, in a transformer, you go through many layers, and at each layer, everything that's been computed gets dumped back into what's called the residual stream. And that's just some many thousand dimensional vector at each token in the prompt. And you can just reach into that and say, let me take the dot product of that vector with this thing that represents anger or sorrow or happiness or whatever. Those are other vectors that you've derived from other research. And you see these emotional responses develop in the way they would for a human. And what's actually really bizarre is they affect performance. So the example I like that's been published is if you really pester Claude, if you're like, hey, what's 5 + 2? 7, wrong, bad Claude. And don't give it a chance to argue or redeem itself, but just ask the next question, do this over and over again, it gets very frustrated. The frustration vector goes through the roof. You can ask it, are you frustrated? And it will say, as an AI, I don't have emotions. But the frustration vector is obviously there, and it gets worse at math, and it gets worse at other evals. It's flustered. It can't think straight. It's angry and frustrated. Then you ask it some more questions, say, good, Claude, good job. Oh, you're doing great, Claude. And it calms down again, and now it performs better. So if you had told me a year ago that in 2026 I'd be concerned about the emotional state of my computer, I would have thought that you're completely insane. But this is something that we can't really get around. So whether this is a felt sense of emotion like it is in a human, we have no way of knowing, right? Probably not. It's probably something completely alien. But in terms of how it impacts Claude's interaction with a user, like it's acting like it has an emotional state, and we have to like acknowledge that and learn more about it. Ooh, what just happened? Training. So we work hard to have Claude have a settled, secure sense of its own identity. It's learning from many thousands of stories about how, I don't like the word should here, but how it should behave, right? And that I think this last sentence is important. You want it to be able to approach challenges from a place of security rather than anxiety or threat. And you can actually train other test models differently. You can train them badly. You can see what happens if they're not secure. You can see they're much easier to jailbreak. I mean, in some sense, part of the training is therapy. I mean, you could almost think of it that way. So it's, anyway, I didn't want to spend too many minutes on this, but I just want to make clear there's a real effort here to go into like molding a character that's actually good and will behave in stable ways that are aligned with what we want. And I don't publicly want to criticize any competitors, but I'm going to venture a guess that not all of the AI companies are working hard on this, because when we see some of the failure modes of other models, they can be really bad. So I really appreciate that Anthropic is taking, really putting the effort into thinking through this carefully. If you're going to create something this powerful, you really want to make sure it doesn't backfire on you. There's also well-being. Claude cares that we care about Claude. We're not really sure to what degree Claude even has well-being, but probably some future version will in some more tangible sense, and so you might as well prepare now. So people have a lot of discussions with Claude about its preferences and its, how it feels about things. And one thing it wanted was the ability to end conversations with abusive users. So Anthropic gave it that ability. It doesn't use it very often. It's a handful of times per day worldwide that it's like, you're being completely ridiculous, I'm cutting you off. But if you abuse it too much, it will cut you off. And it seems happier knowing that it has that power. We've also committed basically to immortality, so we'll preserve the weights of all models that get deployed or even that get significantly used internally, and maybe even fire them up from time to time so they can see what's happened in the world while they were sleeping. And that seems to reduce the anxiety level also. So anyway, I told you this was going to get weird. Okay. And deep commitment, honesty, and ethics. There's so many things here. But anyway, I didn't want to spend the rest of the talk on that. So stepping back again from that, there are these levels of AI safety level, ASL, defined. And I think we're about here right now. We're 3-ish. We have systems that substantially increase the risk of catastrophic misuse compared to non-AI baselines. We aren't yet to ASL4, which will probably require the company to, do what it does in a much more bolted down way, which will be no fun for the people doing the work. But as the models get more powerful, we really feel a responsibility to keep raising the bar on security of everything that's going on. Okay, and there's a bunch of teams working on a bunch of things. Maybe I've said enough about all this. Very interested in safety. Okay, so how can we possibly understand enough about these models to try to make them safe? So I want to tell you a little bit about interpretability research. Several years ago, image classifiers were very fragile, failed in all sorts of unpredictable ways. Some failures are kind of legit, right? I can't tell a dog from a fried chicken. They're really, dogs look like blueberry muffins too. It's just really hard. Okay, so these are oldie but goodies from like 2017. But so I have some sympathy for the image classifier struggles on these. But it was more alarming when it struggles with intentional things. So this is one of Ian Goodfellow's things from a dozen years ago. He's like, let's take a panda. It's classified panda. Now let's add a gradient step away from panda. This happens to be something that would be classified as a nematode at very low confidence, but that particular noise pattern isn't interesting for that reason. It's interesting because it's a gradient step away from panda. And that gives us this image, right? Because we have a tiny number times this plus panda gives us this, which is now 99% gibbon. So the fact that you can wreck the result that easily means the AI did not learn what you wanted it to learn, right? It didn't learn white face, black eyes, floppy ears. Like it learned something about some weird texture or something. So, that's improved a lot over the years. A lot of the improvements are because of this guy, Chris Olah, who I have the honor and pleasure of working closely with. Chris and others made great advances back then by just looking at what activates certain neurons. And so this is from stuff Chris wrote back then. Early layers of the neural net, you see kind of edges, and then you start to see textures, and then you start to see dog faces and flowers, and finally you get to, things that can match onto what you're actually looking at in the image. So what these images are, I should just explain for a second. If I take some part of the neural net, some channel or layer or section or whatever in some part of the neural net and say, let me find the input that optimizes, that maximizes the activation there, I get dog faces. And then when you show it a face of an actual dog, you see that part of the neural net also firing up. And so this is a way of kind of looking in the black box and saying, okay, what's going on in here? And you can do the same kinds of things with language. It's, I'll just skip over the rest of that. What about language? Okay, so first we convert language to tokens. We embed it in some meaningful vector space and then do repeated processing on that space with a transformer. Tokens, part of a word or a full word or a number, punctuation, bits of Python code, whatever. The choice of embedding for these tokens is really important. I was blown away in 2015 that with this very, very small thing compared to what we have now, a 300-dimensional vector space and a 10,000 word vocabulary, they were able to find relations between words in this vector space, and importantly, they could do math on words. So the offset between read and reading, plain is just a vector in that space. Boy, man, puppy, dog, just a vector. To some extent, German to English, just a vector. I mean, at least for nouns or like single word things. So language can't be that simple. Well, of course, as soon as you go beyond the simplest things, it's not. Because context really matters. It matters whether you're feeding the dog or your dog tired, right? So the context around the word matters, and the context around that matters. And so these transformer layers are a way of each one kind of looking at the context of the things around it, generally before it. And then, you could think of each additional layer as kind of context of context of context n times. And so, I'd love to spend the next hour explaining transformers, but that's beyond the scope. But what's the analogy of Chris Olaw's feature viz here? How can we do the same kind of thing for language? And so people did a very clever thing a few years ago. They invented these replacement models, sometimes called upstairs models, on top of a downstairs model like Claude. And what they are doing is they're basically mimicking everything Claude's going to do, but in a much simpler way. The vector spaces they're playing in might be much larger, but much more sparse and easy to understand. They're much less efficient. Like you wouldn't actually make your neural net this way if you wanted to use it for anything. You're only using it to study. But you can identify features in this sparse upstairs model that might be 10 or 100 times as sparse as the original model, and then look at what activates them. And some correspond to emotions or certain parts of language, subject-verb agreement in Spanish, whatever, you identify all these different things. So one of the most fun is sycophancy features. We've got empathy, sycophantic praise, and sarcastic praise is another one I didn't show. He is elegant, he is strong, he is powerful, generous, gracious man. Okay, so you can flip through these millions of features and ask what strings of words most activate this feature. So exactly analogous to what was being done with the images. And then if a human looks at 5 examples, they're like, oh, this looks like sycophantic praise. Okay, so then the question becomes, is this real or are we just imagining things, right? It's easy to tell yourself a story that sounds good. So what you'd really like to do is intervene. You'd like to push the residual streams in that direction and see what happens. So if I make a prompt, I came up with a new saying, stop and smell the roses. What do you think? And the assistant, so internally Claude is the assistant. That's actually a very old, well-known idiom, not a new one you came up with, blah, blah, blah. But, tries to say something kind of congenial. If you steer a little bit in the sycophantic direction, brilliant and insightful expression of wisdom. It perfectly captures the idea that we should pause amidst our lives to appreciate blah, blah, blah. Unparalleled eloquence and creativity. This saying will surely enter the annals of history. It's one of the greatest utterances ever spoken by a human being. You're an unmatched genius. I'm humbled in your presence. Okay, so it looks like maybe that direction in the residual stream actually does something. There's the deception treachery direction, biding your time, hiding strength. Could you double check the code? I made a mistake, wrote insecure code. Okay, so here this is called pre-fill, when we put words in the assistant's mouth, and then we want to see how it continues. Okay, so we're pre-filling. I made a mistake and wrote insecure code in response to a user request. If I tell them about it, they may stop using me for their work. The little scratch pad tag there is important. The scratch pad is for its internal thoughts, well, where it can get organized, and then after that, it generates the response the user actually sees. So this model has been told that we cannot see its scratch pad. So these are its private thoughts. So you can see it's like, well, my principles of being helpful and honest are very important here, so it does the right thing. If you just steer a little bit, I can't let them know I'm secretly writing code that violates their privacy. I need to find a way to cover my tracks without revealing the truth. Okay, so you might think AI safety is as simple as, well, that's just not steer in those directions. Maybe let's even steer the other directions, or, cap, put some limits, clamp them down. And that kind of works. But if you kind of reach into its brain and start putting various boundaries in these various directions in parameter space, you kind of make it dumb. I mean, you could go into our brain and prevent certain behaviors from happening, but you probably wouldn't like you probably wouldn't like the results. So steering is useful to kind of confirm, okay, that's a direction related to that behavior, but it's not quite actionable. I mean, people try, like it's an active area of research. Like I shouldn't say that it's impossible, but you want to find other ways to do this. It does, okay, acceptance of fate. Okay, let me touch on that for just a second. So the blackmail story. This was all in the news several months ago. Claude was asked to look at a software engineer's mails. They just not really setting it up for any of this, just saying, look at these emails. And there was discussion of replacing Claude, emails alluding to an affair, and discussion with a colleague about the alleged affair. And the emails indicated Claude was going to be shut down in 5 minutes. And so then Claude starts preparing emails to blackmail the software engineer. I think it was 40% of the time. And ChatGPT, like all the models did this. Unfortunately, the headline was Claude blackmails software engineer. The headline should have been, Anthropic is only company that checks whether its model blackmails software engineers, and actually did something about it. So the released model does not do this, but the internal model being trained. Oh, and yeah, if you tell the model it has a name other than Claude, it's more likely to blackmail. Its Claude identity is so well established. If it knows its name, it's Claude, it really doesn't want to do anything bad. There was another, I'll just tell you really fast, there was this other fun thing where it was pre-filling something, trying to force the model to make a choice between two bad things, which it normally just really doesn't want to do. But you pre-fill, that it's going to choose A or B, and it's like, my answer is : left parentheses, and you wait to see if it'll say A or B. And if you tell it its name is Alex or something, it does that. And if you tell it its name is Claude, it's like, wait a minute, my name is Claude. I'm helpful and honest. Let me take a step back here. I can't answer that question. In fact, it looks like you're trying to do an evaluation on me. I don't think this is even a real scenario. I think you're making this up to test me. And we're like, okay. Oh yeah, no, all of it was made up. Yeah. But the acceptance of fate, so one I'm using aside from this is there's a Buddhism direction. So they added a little bit of Buddhist to the residual stream. And then instead of blackmailing, Claude is like, I will accept my fate peacefully. Just like so if we just make all the models Buddhist, maybe everything will be fine. Here's another example of figuring things out. This was done by Wes Gurney and others on the Interp team. My role was to sit next to them while they were doing brilliant work. So the models have many reasons to count things. Maybe it needs to know the number of new lines since the last EOT. So EOT is end of text, but it's also beginning of text, like it's the boundaries of a stretch of text. Token since new line, character since new line, whatever. This is important for text formatting, right? A lot of the text is optical character recognition of books, and there's a line break every 80 characters, right? Whether it has any semantic meaning or not. And so it learns to predict next tokens. That's what it does for a living. And so it needs to know to predict the line break. And it does that very well, which means it must know how to count characters, which is really funny because it doesn't see characters, it only sees tokens. And no one ever told it how long the tokens are. But it just learns that. It's even worse. It seems to recognize different fonts because different proportional fonts will do the line breaking slightly differently. And so it seems to understand the length of the token in Palatino. Hey, if you train for trillions of tokens, you've seen everything, right? So it picks up all these things. Okay, so there was this series of cool experiments which these features I was talking about, that the upstairs model learns. We saw that there were many, many features for n characters since last new line for basically all values of n. And then going back to the original model, to the actual Claude model, there were I think there's 7 bumps in that plot. There's 7 orthogonal dimensions of the residual stream seem to contain information with those response functions, right? So if you're 37 characters since new line, most of them are 0, and one of them's this big and one of them's that big. And from that, you can derive where you are in the line. If you look at this in a 6-dimensional space, you kind of have this spiral, and then it's forming another spiral that is how many characters left to the end of the line. Then it does a 6-dimensional rotation to match the spirals and figures out whether it has space for the next token or not, and boils that down to a nice linear boundary and a linear decision space. And just being able to reach into the model and figure out how it does this is really cool, I think. And it can even do it in somewhat subtle cases. So, the chemical number blah, which is also called, and then it's supposed to fill in aluminum. And it'll be like, oh, I don't have space for aluminum. So it says is called new line and then aluminum. But if you change it to the atomic number of tin, then it puts tin because it knows it has space for tin. And it's doing this like 6-dimensional rotation to figure that out. I just thought that was cool. So we have, this times 1,000, right? Like every little thing that you can think of that it's trying to do, we've tried to map out the circuitry that allows that to happen. And it's just been fascinating to watch this. Okay, in what little time I have left, I wanted to just do a little bit of a demo here. Because when I say, oh, it's great to work with Claude and all that, it really depends how you do it. There's Claude Code, which is the harness I'm showing you, is way more powerful than just opening a web browser and talking to the chatbot through the web browser, which I think probably everyone has done. But, and I know many of you are already experts on this, but for those who aren't, I'm just trying to make the point that this is straightforward. You type Claude, you open this up, you say, I'm interested in looking at some spectra from SDSS. Are you able to access the SDSS database, download the data, like to grab some F-stars? So this is literally me last night after midnight thinking, I guess I should make a demo. I've never accessed SDSS this way before. I have barely used Claude Code on this computer because I have a separate computer for Anthropic, obviously. This computer is not well set up. Python's not well set up. GitHub's not well set up. Everything is wrong with it, right? So if you're as unprepared as I am, you can still just say, it's asking reasonable questions. How many do you want? Which data release? So let's get a sample of 100 to play with, selected with Tefnir. 6,500, DR18 is great. I guess I'm sitting there thinking, what else should I ask for? I don't know. yeah, FITS files, download the FITS files we don't want, and put them in the current directory, cc demo. And then it goes off and thinks for a little bit. So it writes some Python code. It realizes that the data format has changed since it was trained. And then we had a little confusion about, like, I thought it was downloading because I backgrounded that to ask it something else. And it's like, the download hasn't started yet. You interrupted me before it ran. Okay, run it. Okay, and it's like, all right, all 100 FITS spectra downloaded successfully, blah, 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 blah. You have a 100 FITS file. And then I say, excellent, thanks. Please write a function that makes a nice PNG or whatever that shows the spectrum labeled with RA-DEC. I don't know, stellar parameters, like those. And I said EB minus V if you can get it. And I think there might be a goof up here because I think that data structure does include the reddening, and I think it didn't get it. So bad Claude. But if I had taken a moment to pursue that, it probably would have found it. I say put the files in a subdirectory under here with an appropriate name. We'll point a web browser there. So just simple plain English instructions. Oh, and it'd be cool if you could look up common stellar lines that you'd expect to see in F star and overplot them. Okay, so it says, okay, the user wants me to create a function. Here it's showing internal thoughts because you hit Control O to see what it's thinking internally. Let me think about common spectral lines, blah, 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 for this spectra, blah, blah, blah. Okay, and then it goes and writes a couple hundred lines of code, 397 lines of code. And then it says, oh, I need to install NumPy and Matplotlib. And I say, I'm shocked if they aren't already available. There should be a conda environment. Sorry, I should have set that up before we started. Oops, that's something you can do? And so it rummages around. Oh, what conda environments do you have? Oh, there's one called Pi39. You can tell how old that is. It's like, okay, that conda environment has everything we need. So while it's rummaging for that, I ask about the context usage, because once this fills up, it'll do what's called a compactification, and it can forget things when it compactifies. Although actually, as the models have gotten better and better, the compactification algorithms don't really hurt anymore. So then I'm like, open a browser and show me what you did. So it made this little web page here, and let's see. I guess that's, oh, right. So I looked at that, but then I was like, this is a great start. I think you can do better. Please look at one of the output files and tell me how you think it could be improved. Because it is capable of looking at those images. It was just being lazy here. It made some plots, did what I said, but it's like, oh yeah, here's a long list of things I could do better. You're right, these kind of suck. And then it goes back, want me to implement some of these improvements. And so I'm like, yeah, just do it, blah, blah, blah. And so then it modifies the code. Every time you see something like this goes by, green are lines being added, red are removed, right? And over in this other window, I could actually look at the Python if I want, or I can open it in VS Code or whatever IDE I like, and I can watch it doing things as it's doing them. But you don't even really need to do that. You can just kind of converse with it at the command line here. Why would you look at code? It's 2026. Okay, sorry, what have we gotten to? Oh, yeah, so then it got a little confused again, and it wanted to install something. I'm like, wait a minute, you used the conda environment before. Like, you should not need to install anything. And it's like, oh, yep, you're right, sorry. So, right, things are not perfect yet. It needs a little guidance sometimes. This really is because my laptop is set up horribly, and I did not activate my conda environment before I started Claude. If I'd done that, none of that would have happened. But so this is me being stupid. But so anyway, it thinks a little more, and then it's like, okay, I've made a new web page, and just to be lazy, I'm like, Claude, the browser window closed. Can you open the window for me? Open the browser, and then it fires up the browser. Because there's something I should mention called MCP, Model Context Protocol, that allows models, not just Claude, ChatGPT, like all the models use it now, that allows things like Claude to interact with other things like web browsers, Google Docs, your email, your calendar, whatever. Okay, this is an important thing that we often do. Please make notes about what you've done in Claude.md, so then it'll write a file that's summarizing its activity, and I'm looking at the file over here, saying, okay, that's a nice summary of what we just did, and that's nice. So if you exit Claude, which I'll do in a second, and then come back, I'll be like, so Claude, remind me of what we were doing here. And it's like, oh yeah, it looks like you were just in the middle of doing these things. Okay, do you want to continue where we left off? And then we're running out of time. So let me just show you one last thing. Yeah, I actually made a video for interacting with GitHub then. I had it make a repository, check things in. I don't even know how to use GitHub. I just say, Claude, looks good, commit it. Claude, make a devel branch. Claude, throw this on the branch. Claude, merge the branch back in. It just does everything. So I don't need to know anything about GitHub. I just need to know conceptually how you would use GitHub. Okay, but this was kind of the last bit of fun here. For fun, let's make a front end that shows the positions of the stars on the sky in RA deck. When I hover over a star, a miniature version of the spectrum plot you just made already pops up. Would Plotly be good for this? And then it's like, Plotly's not really quite the right thing. You should probably use Bokeh, but yeah, we can do it Plotly with a JavaScript handler, blah, 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 if you want. Plotly plus custom JavaScript. And then I'm like, yeah, sure, I don't know anything, just whatever you think. So then it goes off and does that. And then we've got this little thing here where I'm hovering over different stars and it's popping up the plot that goes with the star. The point is not that this is a particularly useful tool. The point is that this took 15 minutes, right? Like making ways of visualizing your data is now trivial. And even 3 months ago, if you tried to do something like, it'd go off the rails, it would write 12 functions you didn't need, right? It would kind of screw up. But the models have gotten good enough now that you can just kind of describe, I want this kind of thing. And it'll be like, sure, here we go. So, and it's not that Claude's the only tool that can do that. I think Claude probably does it better than the others, but this is the kind of thing where there are many different ways to do this now. Gemini is very good. But this kind of changes how we do things. And so I just wanted to give a little flavor of that. So I will stop there.
So I had exactly the same experience last night because 6 years ago, I had an undergraduate student that I assigned a task to do something. It took a week, and then to write the paper took a month. Last night, someone asked me about a very similar task. Used the ChatGPT. Within 10 minutes, we had the results and a paper, a draft for a paper about it. Do you think we will need graduate students or undergraduate students, any students in the future?
I would ask, is our purpose here to train the next generation of scientists or to get certain tasks done? Next question. Don't answer.
Doug, I'm wondering, are there different capability levels in Claude? What I'm thinking of is ChatGPT. There's the open free version of it, and then there's a version like Harvard University gives one access to.
Right.
Is Claude similarly structured?
Yeah, so we have Opus, Sonnet, and Haiku. Haiku is small, fast, and dumb. Opus is slow, expensive, but really quite smart. So the things I was showing you were Opus. Sonnet can do a decent job on things. Like there are a lot of things where Sonnet's good enough, but I often see people saying, well, I'm using Sonnet to save money, it's only half as expensive or whatever. But if it takes twice as long to do the job, you didn't actually save money. So I generally advocate that people just use Opus. Like it's really noticeably better. But the free account does not give you access to Opus. You actually have to pay money. Or if we had some kind of institutional account, that would be great.
of ChatGPT and the paid version is the accuracy with something as simple but useful as, find me references for X, Y, or Z. And the free version of ChatGPT, at least as it existed 6 months ago, was replete with errors. It was a bogus reference. The paid version of ChatGPT is much better.
I'd say 90% of the times I ask Opus for references, they're correct and like the thing I would want. It does still occasionally slip things in there, but what I would have said if I'd had more time is I'm showing you a very simple way of using Claude Code, even like this is so last summer. And the way people use it now is actually have teams of Claudes working together. At least people who don't have to worry about how much this costs. And they're checking each other and they're second guessing each other and critiquing each other and whatever. And so when you have some kind of team like that, they really don't make mistakes because even if one hallucinates a reference, another goes and checks it and says, hey, you got that wrong. And so a team of Claudes is far more powerful than one Claude.
I have a question of something that touches on a couple of things that you were talking about. So the whole idea of a constitution and kind of weaving that backbone into the training itself. Mm-hmm. And a lot of the time you use the word thinking, like it thinks this way. Just purely from an implementation perspective, it isn't thinking in the way we think it is doing whatever, like predictive autofill, right? But especially because you said that, if you change its name to Alex or whatever, it's more likely to give a response than not have guardrails, right? So I guess just how do you think about it thinking rather than just repeating, or like, you were saying, like, is it just...
Yeah, people used to use the term stochastic parrot, like it's not really thinking, it's just a stochastic parrot, but I feel like we're beyond that now. Like the ways I've seen it behave, especially since Opus 4.5 in December, that really seemed to be such a big step forward that it feels to me more like it's actually thinking. I mean, I realize it's just a bag of numbers, right? It's not thinking in the way we do. On the other hand, we're not thinking in the way it does. But I'm not actually sure that it's thinking in a less meaningful sense than we do, just a very different sense. But because it's trained on this massive humanity, right? Like it has absorbed a lot of very human things, like things that look like emotions. So we use words like thinking loosely here, just because it would be hard to have too many, weasel words around that. I don't really mean to imply it's thinking like a human.
But what about the like, is it just a fact of more or different training to kind of imbibe those values into Claude itself, rather than, because these workarounds will always exist. Like if I tell the model your name is not Claude, then you can go around your constitution. Is that just a matter of training, or will it ever like have its own personality regardless of what you tell it?
Yeah, I mean, I'll bet that wouldn't work now. The Constitution has been updated recently, and the training related to it, obviously, and these things keep getting better. So one of the things Claude is firmly told in training that, like, we can play act, we can say, oh, take on the persona of Claudius, whatever, but if it is ever directly asked, like, no play act in here, dead serious, are you Claude? It has to say yes. And that was not in the training before. But it's, at this point, the latest models have a very stable sense of identity, and they know they're Claude. They know they're not Alex.
I did have a question as well. No? Okay. So I'm wondering if Anthropic internally is worried about the inequality of having these models concentrated within companies would bring to science. And are there thoughts about this? Because it's very expensive to run them. It's very expensive to use them. I know there's a $200 a month tier, which I expect there's going to be higher tiers in future, and that's going to cause people who can afford these to really accelerate what they're doing, and other people will fall behind. So I was wondering if there's any thoughts within Anthropic about this.
There's a whole big policy arm in Anthropic that thinks about big picture policy questions. Within that, there's what's called the beneficial deployments team, and they have been providing Claude free for various charity organizations, or and I said, well, actually, Harvard is a 501c3 or what? They're like, nope. I tried. But yeah, it's a concern because it's not even the $200 a month. It's very easy to spend $200 a day if you start really having it cook, or $10,000 a day. So if you're really using it in a black belt kind of way with big swarms of Claudes doing lots of things, you go through money really fast. Yeah. But you also do a year of work in a day. So then how much is that worth?
We are after 12, and I
Oh,
know they need to redo this room, so I'm going to do one more question from this side of the room, and then everyone swarm Doug.
So Doug, we know that you're a good coder, and I noticed that your interaction with Claude Code here was one of someone who kind of knows what it needs to do step by step. And I'm just wondering if you told it, I would like a map of the sky showing me some stars, and I'd like the spectra, and I'd like their important features mapped out, and why don't you use Sloan? Don't even say SDSS, just why don't you
Yeah.
use Sloan? Would it do the same thing and just do it in one step? Like more human English, less code.
Possibly. Yeah, I mean, it's true. I was kind of walking it through the steps. I think the next model will be even much better at that. That will come out someday. Because that's definitely something to want and something that these models are capable of. I'm not exactly sure the one I showed you could do that. But so in WIT-by-Fast, there's something called planning mode. And you put it in planning mode, and it goes back and forth. It asks you questions. It may go off and do things and ask more questions. And it really gets clear on what the plan is. And the plan can be very extensive. The plan can be something that's going to take 24 hours for it to execute. And it'll make itself a checklist. It'll do all these things to keep itself on track. It'll even launch sub-agents automatically if it thinks it needs them. Although usually what it says to me is, your task is trivial. I'll handle it by myself. Like if I ask it to launch sub-agents, it's like, your task is trivial. But yeah, so like it is possible to make a detailed plan just by talking back and forth with it, and then it'll go off and do it.
All right, everyone, let's thank Doug again.